MS Ramaya University of Applied Sciences.
Hi students, title of the experiment Assay of copper sulphate. Aim to find out the percentage purity of given sample of copper sulphate by performing redox titration. Apparatus required for this experiment are burette 50 ml, pipette 10 ml, burette stand, iodine flask, volumetric flask, funnel and digital balance. Chemicals required for this experiment are sodium thiosulphate, potassium dichromate, starch mucilage, potassium iodide, concentrated hydrochloric acid, potassium thiocyanate. Principle: assay of copper sulphate is based on redox titration and the method involved is iodometry. Copper sulphate reacts with potassium iodide in the presence of acetic acid gives cupric iodide. Cupric iodide is unstable and gets decomposed to cuprous iodide and free iodine. This is a reversible reaction. Cupric iodide is insoluble and cuprous iodide is slightly soluble. The liberated iodine is titrated against sodium thiosulphate using starch as indicator. Iodine oxidizes sodium thiosulphate to sodium tetrathionate and itself gets reduced to sodium iodide. When the blue color is disappearing, potassium thiocyanate is added. As the reaction leading to the liberation of iodine is reversible, it is completed by the addition of potassium thiocyanate. It converts cuprous iodide to cuprous thiocyanate. Potassium thiocyanate is added only at the end of the titration, otherwise iodine will be absorbed by cuprous thiocyanate. Endpoint is blue to colorless. Principle for standardization of 0.1 N sodium thiosulphate. Sodium thiosulphate is standardized by potassium dichromate, which is an oxidizing agent in acidic medium. Potassium dichromate liberates 3 nascent oxygen. Potassium iodide is converted into hydrogen iodide by reaction with hydrochloric acid. Hydrogen iodide is oxidized to iodine by nascent oxygen. The liberated iodine reacts with sodium thiosulphate to form sodium iodide and sodium tetrathionate. Starch mucilage is used as indicator, which is added near the end point as it gets hydrolyzed by hydrochloric acid and iodine gets trapped in the matrix of starch. Due to this, there is no continuous liberation of iodine. Endpoint is blue to apple green. Experimental procedure for standardization of 0.1 N sodium thiosulphate. Weigh 0.49 grams of potassium dichromate into a 100 ml volumetric flask. Dissolve and make up the volume with distilled water. Transfer 10 ml of the solution into iodine flask. Add 3 ml of concentrated hydrochloric acid and 10 ml of 10% potassium iodide. Close the flask immediately with the lid. Keep it in the dark for 15 minutes with occasional shaking. Titrate the liberated iodine with sodium thiosulphate until it turns pale yellow color. Then add 1 ml of starch mucilage. Continue the titration until the blue color changes to apple green. Repeat the titration until concordant readings are obtained. Experimental procedure for assay of copper sulphate. Weigh accurately about 1 gram of copper sulphate into 100 ml volumetric flask. Dissolve and make up the solution with distilled water. Pipette out 10 ml of the solution into iodine flask. Add 1 gram of potassium iodide followed by 3 ml of glacial acetic acid. Close the lid and allow the mixture to stand for 15 minutes with occasional shaking in a dark place. Then add 1 gram of potassium thiocyanate, mix well and titrate the resulting solution against 0.1 N sodium thiosulphate until it becomes pale yellow. Then add 1 ml of starch mucilage and continue the titration until it becomes colorless. IP factor. Each ml of 0.1 N sodium thiosulfate is equivalent to 0.02497 grams of copper sulfate. The titer value for standardization of 0.1 N sodium thiosulfate and assay of copper sulfate is tabulated. Calculation. Normality of potassium dichromate is determined by using the formula N equal to weight taken multiplied by 1000 divided by equivalent weight multiplied by volume taken. This gives the normality of potassium dichromate solution. Using the normality of potassium dichromate solution, normality of sodium thiosulfate is determined by using the formula V1N1 equal to V2N2, where V1 is the volume of potassium dichromate and N1 is the normality of potassium dichromate, V2 is the volume of sodium thiosulfate and N2 is the normality of sodium thiosulfate. From this, normality of sodium thiosulfate solution is determined. By substituting the actual normality of titrant, percentage purity can be determined by using the formula IP factor multiplied by assay titer value multiplied by actual normality of the titrant multiplied by volume made up multiplied by 100 divided by volume taken multiplied by expected normality of titrant. This gives percentage purity of given sample of copper sulfate. Thus, percentage purity of given sample of copper sulfate is determined.
Hi students, name of the experiment assay of copper sulfate by iodometry. Aim to find out the percentage purity of given sample of copper sulfate by iodometry. The chemicals required for this experiment are copper sulfate for which the percentage purity of the sample is to be determined. Potassium dichromate is a primary standard. It is used to standardize sodium thiosulfate. Potassium thiocyanate is added at the end of the titration to convert into cuprous thiocyanate, which is sparingly soluble in water than cuprous iodide. Potassium iodide is used for the liberation of iodine. Glacial acetic acid is used to provide acidic medium. 0.1 N sodium thiosulfate is used as the titrant. Potassium iodide solution is used for the liberation of iodine. Concentrated hydrochloric acid is used to convert potassium iodide into hydroiodic acid. Distilled water is used for dilution. And the last is starch mucilage as the indicator. The apparatus used for this experiment are spatula, butter paper, volumetric flask 100 ml, iodine flask 250 ml, measuring cylinder 10 ml, beaker 250 ml, funnel, pipette 10 ml, burette stand and digital balance. To determine the percentage purity of given sample of copper sulfate, the titrant used is 0.1 N sodium thiosulfate, which is a secondary standard, and it has to be standardized by using a primary standard. Here the primary standard used is potassium dichromate. Now let us start the standardization of 0.1 N sodium thiosulfate. For standardization, chemicals required are potassium dichromate, potassium iodide solution 10%, concentrated hydrochloric acid, distilled water, 0.1 normal sodium thiosulfate, starch mucilage. Take the butter paper and weigh 0.49 grams of potassium dichromate. Tare the balance to 0. Tare the paper weight to 0. Then add the sample 0.49 grams. After weighing 0.49 grams of potassium dichromate, it is transferred into 100 ml volumetric flask using funnel. Make up to the mark by using distilled water. Transfer 10 ml of potassium dichromate solution to iodine flask. Transfer 10 ml of potassium dichromate solution into 250 ml iodine flask. Now add 3 ml of concentrated hydrochloric acid into using 10 ml measuring cylinder into the iodine flask. Then add potassium iodide solution 10%, 10 ml into measuring cylinder. Transfer into the iodine flask. Stir the solution and keep the iodine flask in dark with occasional shaking. Keep the iodine flask in the dark for 15 minutes with occasional shaking. Meanwhile, rinse the burette with 0.1 N sodium thiosulphate and then fill the solution up to the mark. Fill 0.1 N sodium thiosulphate till the mark. After filling the burette, keep it in the stand. Take out the iodine flask from dark. Titrate it with 0.1 normal sodium thiosulphate solution. Titrate the solution till it becomes pale yellow. After it becomes pale yellow, add 1 ml of starch mucilage. Add starch mucilage indicator. Then titrate with 0.1 normal sodium thiosulphate. The end point is the appearance of apple green color from blue color. End point is the appearance of apple green color. Repeat the titration to get concordant values. This is the procedure for standardizing 0.1 normal sodium thiosulphate, and now we can do assay of copper sulphate using iodometry. For assay of copper sulphate, chemicals required for the experiment are copper sulphate, potassium iodide, potassium thiocyanate, glacial acetic acid, sodium thiosulphate 0.1 normal, starch mucilage, and graduated 10 ml pipette. Weigh 1 gram of copper sulphate using butter paper. Tare the paper weight to 0. Then add 1 gram of copper sulphate. Weighed 1 gram of copper sulphate and then transferred to 100 ml volumetric flask using funnel. Make up to the mark using distilled water. Transfer 25 ml of copper sulphate solution into 250 ml iodine flask using 10 ml graduated pipette. Transfer 25 ml of copper sulphate solution into 250 ml iodine flask using 10 ml graduated pipette. Using butter paper, weigh 1 gram of potassium iodide. Make it to auto 0. After keeping butter paper, tare the paper weight to 0. Weigh 1 gram of potassium iodide. Weighed 1 gram of potassium iodide, it is transferred into iodine flask. Stir the solution. Add 3 ml of glacial acetic acid into iodine flask using measuring cylinder. After transferring, close the lid, then keep in the dark with occasional stirring for 15 minutes. After the completion of 15 minutes, take the iodine flask from dark. Fill the burette with 0.1 normal sodium thiosulphate solution up to the mark. And fix the burette in the burette stand. Using butter paper, weigh 1 gram of potassium thiocyanate. Tare the balance to 0. Keep butter paper. Tare the paper weight to 0 grams. Then weigh 1 gram of potassium thiocyanate. Weighed 1 gram of potassium thiocyanate is transferred into 250 ml iodine flask. Stir the solution. Titrate against 0.1 normal sodium thiosulfate until it becomes pale yellow. Add 1 ml of starch mucilage. Add 1 ml of starch mucilage and titrate till the solution becomes colorless. The endpoint is the colorless solution. This is the procedure to determine the percentage purity of copper sulfate by iodometry.
At MSR UAS, we spark your imagination unlike any other.